fundamentally the purpose of a product is to embody a process. And so I've always sort of kept that same thread of thinking, again, whether it's surgical equipment or it's industrial robotics, it doesn't really matter. As long as you take the time to really understand the process that you're trying to affect and that you're trying to improve, and you build real system requirements and you really explore the solution space and understand what you're looking at. In a lot of ways, everything translates really well as long as you take the time to understand the process. All the technology translates incredibly well.
Bioprocess hardware development sounds straightforward until you try to build it. Anthony Catacchio, CEO of Product Insight, has spent years helping biotech companies navigate the challenges. Because most automation projects fail because teams never clearly define the problem they're solving and over-engineer solutions with unnecessary complexity. Today, he reveals his phased approach to developing robotics and AI-driven systems that actually work, reducing risks, accelerating timelines, and producing validation-grade data without burdening internal teams with complexities they are not equipped to handle. Let's dive in. Are you juggling the complexities of CMC development while trying to enjoy the beauty of biotech? Have you ever wondered if there's a way to simplify bioprocessing? Welcome to the Smart Biotech Scientist podcast, where we're diving headfirst into the very challenges you face. We're breaking it down, demystifying the jargon, and giving you the keys to unlock your full potential. I'm your host, David Brühlmann, and I get it. With 15 plus years in the biotech industry, I face the same challenges you do. There's a way to simplify and streamline so you can remove complexity, you can skip trials and errors, deliver without delay your groundbreaking therapy to clinics and market, and still enjoy every single step. Do you want to learn how industry experts and I did it? Grab a cup of coffee and your favorite notebook and pen. Now is the time to take your bioprocessing game to the next level. Let's smarten up biotech. Welcome, Anthony. It's great to have you on today.
Yeah, it's great to be here, David. Really excited. I can talk about robots forever, so I'm always excited when I get a chance to.
That's awesome. Anthony, share something that you believe about bioprocess development that most people disagree with.
I guess I don't know what everybody agrees or disagrees with me, but one of the things I think that's going to be really interesting to see over the next several years is as we see more and more generalized robotics and sort of the industrial robotics technologies all kind of creeping further and further into lab processes of all kind. I mean, absolutely in the CMC and bioprocess world on the manufacturing side, but also on the research side, and accessibility goes up and up, then deployment should go up and up with it. And so that's what we see a lot of, whether it's cobots or it's AGVs, wheeled robots that move stuff around in labs. We expect more and more of that kind of stuff. I think there's this idea that biotech and lab are wholly different from industrial robotics. And realistically, I think that's going to be the biggest thing that people see over the next several years is it's not so much that you're going to see tons and tons of lab specific or bioprocess specific robotics and AI. You're going to see a lot of the stuff that's been the cutting edge or has been really well proven out in a lot of these industrial spaces start to make that move from the manufacturing line or assembly, whatever it is. It's going to start to make those moves over into some of these higher value spaces, as obviously these high value spaces, people are really risk averse, but the robotics industry has a pretty long history of bringing automation to complex processes. And I think we're going to see more and more of that kind of migrate across from the industrial logistics, those sorts of spaces where a lot of this stuff's been developed and refined into these somewhat lower volume, higher value use cases. I think that's maybe the biggest thing. A lot of people sort of view their niche as, I don't want to say special, but special. That you can't just use that robot that you use on a factory floor or in a warehouse. You can't use that here. And that might be true in some ways, but the fundamental principles are there. And it's really just about someone making the investment and taking the time to do it right and develop the right systems for whether it's bioprocess or other lab spaces or med spaces where the technology is already there. And the question is just, is someone going to take the time to design the system correctly and create the right quality levels and reliability levels?
Anthony, draw us into your story. What got you started in robotics, automation, and what were some interesting pit stops along the way?
I didn't really set out to be a roboticist. I'm a mechanical engineer by training. My whole career has really been kind of in the new product development space, starting in med device, really. My first job out of college was all about surgical positioning equipment. So it was a small company. The engineers did a lot of stuff there, and that included research and process mapping and really understanding how to bring mechanical systems that, again, aren't necessarily anything novel or specific to the medical world. No, the technology isn't, but understanding how to design those systems in a way that worked well in surgical setting. So I did a lot of work in arthroscopy and in trauma care and that sort of stuff, building medical devices. But really, even as far back as then, it didn't really matter. Are you making a medical device or are you making something for a lab? Are you making something for the automotive industry, right? Principles are all the same. There's a different level of system design is fundamentally what it comes down to. In labs or in CMC, your system and process is just so important because you have so much value flowing through those materials. And so it's not a technology problem, it's a system design problem. And so as my career sort of progressed, I moved from that company to a consulting group. And then when you go into consulting, you see a lot different types of problems. And I got a chance to work on some surgical robots. I got a chance to work on a bunch of other medical devices, different types of, whether it's a cart or implantable or whatever it is, you get to kind of see again all those same basic ideas of engineering and robotics. It's like, well, now you're just applying it. You're building a different type of system around it. And so it was kind of the medical and surgical robotics where I got a lot of experience out of that, as well as sort of starting to move into the industrial robotics space. In the consulting world, as you well know, it's a very referral heavy world. And sometimes you do a medical device project and then someone leaves that med device company and goes and starts working at a robotics company. And they still call you, even though you're the med device guy. They need ideas about how to do robotics and how to design systems so that they can achieve their goals. And so I got a chance to start to kind of get into the industrial robotics world. And over the last 7-8 years, I've really leaned pretty heavily into that on the logistics side and kind of warehouse robotics. And so that's really kind of how I got here. My background really is in product, but really product has always been system in my mind. I really think of product development as the physical embodiment of a process. Products exist in order to enable processes. Whether they physically aren't possible without that product, you're building the product to make them higher throughput, higher reliability, lower labor, whatever it is you're doing. Fundamentally, the purpose of a product is to embody a process. And so I've always sort of kept that same thread of thinking, again, whether it's surgical equipment or it's industrial robotics, it doesn't really matter. As long as you take the time to really understand the process that you're trying to affect and that you're trying to improve, and you build real system requirements and you really explore the solution space and understand what you're looking at. In a lot of ways, everything translates really well as long as you take the time to understand the process. All the technology translates incredibly well. And so I've had that opportunity throughout my career to move through a lot of these different industries and be able to understand, like, wait a minute, this doesn't need to be different and special, right? We just need to make sure that we're using it the right way. And like, well, maybe you can use the same robot that you use in a warehouse. Well, you can use that here. You might need to put a big cover on it. You might need to make sure it stays out of the way, that it can be sterilized. You might need a different end effector, again, with different requirements to it. But fundamentally, the core tech is all the same. That's a lot of what I see in terms of the future of biologic processing and labs in general is just kind of bring the wall down a little bit and showing how those technologies can translate with good system design, fundamentally.
What kind of problems are you solving today in the bioprocess world so that people can see exactly what you're working on today?
Yeah, I mean, unfortunately, the consulting world, the big downside fundamentally is I can never really show anyone the stuff we're working on, right? Because we're always in someone else's R&D world. But a lot of what we're looking at today and the kinds of stuff we're working on, we're understanding how to move things around efficiently. That's a lot of the type of work that you see. And again, it sounds simplistic. And there's this crossover where you need to have people who lab and lab automation. It's very hard to get all of the people out, right? There's a lot of processes where you still need expertise. You still need high touch. And you can't necessarily aim for fully lights out automation all the time. And you shouldn't all the time. So a lot of what we spend our time looking at and thinking about is how to design the systems so that they accommodate today's workflows or the parts of the workflow that really just aren't friendly to automation, while removing those, whether it's physically demanding work or it's just repetitive, slow, high risk to the process type of work. So we spend a lot of time looking at how to set up kind of the entire flow to really enable high throughput automation in that space. You have to be really careful about how you delineate and how you sort of protect the expert's role in those environments. You can't just throw a bunch of giant robots in there and put everything in a cage and make it this completely inaccessible manufacturing line. It's just not realistic. And again, it's not the goal. The goal isn't to eliminate human labor. The goal is to reduce errors and to increase throughput and all those things. So it takes really thoughtful design to bring that automation in a way that doesn't exclude the human labor, but amplifies it. And that's really what we look at a lot. And in robotics, a lot of the time, what's the real job? The job is to pick something up and put it down over there and to not get it dirty or break it or mess with it in any way along that path. And one of the big advancements that we've seen in the last several years, that sort of pick things up and put them down mantra of robotics. People talk about AI and robotics. A lot of the real advancements in the last handful of years is really just in vision systems. So the ability to identify objects, the scaling of what's available for edge compute to do those things, and the models to do that. What that's really allowed for is kind of a broadening of acceptable inputs and acceptable output, where 25 years ago, you had to know exactly where that thing you wanted to pick up was. You have a pre-programmed robot path and it just goes and picks up a thing at this point in space. Today, with vision-guided robotics, you can do a lot more in terms of, I know the thing I need to pick up is over here on this bench. And then you can sort of go find it in a way that you just weren't able to before vision got to kind of where it's gotten today. So it's really that merging of AGVs, wheeled robots, wheeled quadrupeds are an incredible technology, and vision-guided robotics.
We have so many technologies at our disposal now, and you could do a lot of things. But the question I'm often asking myself, what is really making the difference, and where is it just hype? Where is it just the tech guy has a great idea? How do you advise people? Like, what are the best areas to implement these automation or robotic systems?
It's very much a case-by-case basis. So the way our process generally works, we always like to start with a really rigorous problem definition. Implement automation is not a problem. We need to know before we start, what is the goal? What are your challenges? Is it that your problem is throughput? Your problem is you can't hire enough labor. The problem is whatever, error rates, whatever it is. What are we optimizing for? What are we trying to achieve here? And once we understand that, our next step generally we call system concept development or system architecture development, where we're going to take the time to essentially look at, okay, now we understand what the problem is. What are all of the ways we could solve this problem? There's a real challenge in this space where most of the people who know how to understand robotics and understand capabilities and what different technologies you really should use where, a lot of the time their incentives are not very well aligned. If you go and ask someone who sells some particular kind of robot if it'll work for your application, they're going to try really hard to say yes to that question. So one of the things we always try to do first is to lay out all the different ways we could solve a problem. At the end of the day, it's return on investment. Measure the different impacts and outcome of those different system concept and system layouts. You might say, well, you could do this with one 6-degree of freedom arm. And if you do that, you need to develop a custom end of arm tool. And maybe you want to put it on a mobile robot, or maybe you just want to lay this out differently so that robot doesn't have to move. Lay it out like this and put the robot in the middle and put all the work cells it needs to interface with around it. So you kind of walk through usually dozens of ideas at the whiteboard level of how could you arrange this system? What are the real requirements here? And what's just the most optimal way to meet these set of constraints or this set of requirements and to achieve what the client is trying to achieve? And a lot of what we do there actually ends up being communicating with the client. I'll show you 5 different ideas. I already know that none of those ideas are correct, right? I'm not trying to show you a final design the first time we review concepts. I'm showing you a bunch of concepts because I'm trying to understand your problem. People have a really hard time really truly enumerating all of their requirements. And you show them a solution to their problem and they're like, oh, that'd be great, except this, and this. I'm like, yeah, you're right. It won't work because of all those things. But people won't tell you all the requirements until you start showing them visions of how it could work. And then suddenly they understand their application and can enumerate all those things. So that's a huge part of the process for us, is just trying to really cover the entire landscape of how you could solve a problem. And then we can do a lot of things from there in simulation or in just kind of what we call human bot testing, where we'll, instead of deploying robots the way we're talking about deploying them, we'll just deploy people and tell them to behave like robots and see how that works as well.
So it starts with defining extremely well the problem you're solving, then looking at potential solutions. And now, how do you guide your clients in this process? Because you could do a lot. You could have this amazing solution that costs millions. You can have a very simple operation, or you could say, well, don't use the robot because you have people doing the job. Because there is this balance between over-engineering, innovating, inventing new things. What is your take on that?
Again, it's part of what we always try to do in that concept phase. The last thing we want is to be doing a project and spending a client's money and not actually delivering any value. No one likes that. It doesn't lead to repeat business. It doesn't lead to good morale. There's nothing worse than when engineers are working on something and they're looking at it and they're just like, why am I doing this? This doesn't make any sense. Again, that's part of what we're trying to do in that early system concept phase. We had a project that we bid a couple years ago where this company reached out to us and they're like, yeah, we have these parts. They need to be wiped down with isopropyl alcohol and boxed in a clean room or in a clean environment. And we need somebody to make us a robot to put it in this clean room so we can clean these devices and wipe them down and put them in a box. And they sent us this 15-page long RFQ and with all these rules about what the robot could be and not be. And we sat down to bid the job even before we got started. And we looked at it and we're like, can't we just use a glove box and a person? Like, I don't know, just put the dirty things in one side of the glove box, wipe them down with IPA, put them in a box and push them out the other side. And you don't need to build a clean room and you don't need a robot. You don't need any of this stuff, guys. I mean, you could do this. It would work. It's feasible, but you don't really have the throughput to justify this. And you're never going to get rid of every person. And this just isn't complicated enough. And so that was what we went back to them with. We said, hey, here's a quote to build the thing you asked us to build. It's probably $1 million. You're not asking for the moon here. It can be done, but are you sure? Like, are you sure you really need this? Because when we look at it, here's simpler ways we think we could solve this problem. It's funny. I sort of view our peak of our value proposition as talking people out of doing projects. It's funny because obviously it's the inverse of how you make money, right? You need people to do projects and do hard things to have work to do. But at the same time, often people just look at stuff and they jump to the solution and they say, yeah, you could solve that problem with a robot. And it's like, I mean, you could solve that problem with a robot. You're right, but you shouldn't. So that's really the biggest thing. That's a lot of what we're trying to do in that system concept development. We're trying to validate the idea that this is even a project. If there's some massively simpler way to solve the client's actual problem, then we're just going to tell them and have them do it that way. Because at the end of the day, they're going to have some other problem, right? If we solve someone's problem for 10 grand and they thought they were going to have to spend $1 million, the next time they have that what looks like $1 million problem, they're going to call us. And so that's a lot of what we're trying to do, is always validate the solution problem fit is correct and optimal and not a few orders of magnitude of cost wrong. And the only way to do that is to put in the time to say, okay, what are all the ways we could solve this problem? If you don't take that time up front, you just jump in and you go straight to buying a robot and just trying to do the engineering implementation because someone said, hey, go solve that problem with a robot. Oftentimes you end up creating really hard problems for yourself that you really should have just solved with a person. Because there's a thing there about trying too hard to replace the incredible machine that is a human.
You're making such a good point. What I'm hearing is that you need common sense. You can solve a lot of problems, but certain problems are just not too big to solve with a robot. It's simpler, it's cheaper, it's faster. And I totally agree with you that turning down a client saying, yeah, we could do it, but you don't need that. This is actually a way better way of making business in the long term, not on the short term.
Yeah, in the long term. Yeah. Yeah, it has its challenges in the short term. but it's the right way to do it. It's because eventually somebody's going to notice that you could have done this for $1,000, right? And not $1 million.
Exactly.
You generally want to be that person who notices that thing. You don't want to wait for somebody else to point it out.
This wraps up the part 1 of our exploration of Product Insight's phased hardware development approach and why data quality matters for GMP validation. We've also explored why a clear problem definition prevents over-engineering. In part 2, we'll continue this conversation about building automation systems that actually solve bioprocessing challenges without unnecessary complexity. If these insights on hardware development resonated with you, please leave us a review on Apple Podcasts or your favorite platform to help other scientists discover this episode. Thank you for tuning in today, and I'll see you next time. All right, smart scientists. That's all for today on the Smart Biotech Scientist podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. If you enjoyed this episode, please leave a review on Apple Podcasts or your favorite podcast platform. By doing so, we can empower more scientists like you. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.